हाय एवरीवन। तो कल हम मीली और मूरे मशीन के बारे में पढ़ रहा था। कल हम मीली मूरे मशीन के बारे में पढ़ रहा था। मैं सोचा था कि रिकॉर्डेड वीडियोस को रिकॉर्ड करके डाल देता हूँ, लेकिन ना प्रॉब्लम ये है कि मज़ा नहीं आ रहा है भाई। रिकॉर्डिंग में, वीडियो रिकॉर्डिंग में मज़ा नहीं आ रहा है बिल्कुल भी। वीडियो रिकॉर्डिंग में मज़ा नहीं आ रहा है बिल्कुल भी। एक मिनट, मैंने टीओसी का बुक का ही डाल दिया है। उदया, उदया, टीओसी बुक का पढ़ला। पार्ट 1। हेलो एवरीवन। एक बार ये कंफर्म करना कि ऑडियो क्लियर है। दरवाजे को गुंडी मारो, कोई को किसी को अंदर आने दे। आरबीआर को समझा दो, म्यूजिक गलती से भी रुक ना जाए। टकर टकर जो फील करे वो जाके 2 कप कॉफी पी ले। जिसको डांस नहीं करना है जाके अपना बाइस चलाए। ऑडियो तो क्लियर है ना? वीडियो भी क्लियर है। और एक बात आज जरूर बताना कि मैं हैंडसम हूँ भाई। मैंने आज बहुत ही बड़ा गलती किया था। मैंने हेयर कट के लिए गया था और वो आदमी ने बोला कि सर आपका हेयर में सब बहुत सफ़ेद बाल है, तो डाई लगाएंगे। तो मैंने बोला ठीक है भाई, एक बार डाई ट्राई करेंगे। तो बाल पे डाई करा दिया। और उसके बाद वो बोला कि सर आपका स्किन बहुत ड्राई है, तो आप फेशियल करवा दो। तो मैं फेशियल भी करवा दिया। 6,000 हुआ बिल। 6,000, 6,000 बिल हुआ। लेकिन थोड़ा सा भी मुझे फर्क नहीं दिखा है भाई। मैं जैसा हूं वैसा ही हूं, थोड़ा सा भी फर्क नहीं दिखा है। कम से कम आप बोलो कि मैं हैंडसम हूं। मेरा 6,000 आज पूरा ड्रेन में गया। मुझे इतना गुस्सा आया कि भाई, थोड़ा सा तो भी फर्क दिखना पड़ेगा ना। थोड़ा सा भी फर्क नहीं दिखा है। ठीक है। ठीक है। तो तो एक्चुअली कल का वीडियो डिलीट हो गया है। पता नहीं, वो बोला कि और भी हैंडसम दिखूंगा, तो मैंने कर लिया। ठीक है। तो कल का टॉपिक भी आज एक बार रिपीट करेंगे। कल का टॉपिक भी आज एक बार रिपीट करेंगे। बाद में ना कहना कुछ भी, पहले दे दूं वार्निंग। पार्टी चलेगी टिल 1:30 मॉर्निंग। बाद में ना कहना कुछ भी, पहले दे दूं वार्निंग। पार्टी चलेगी टिल 1:30 मॉर्निंग। ठीक है। 1:30 तक तो पार्टी चलेगा ही चलेगा। तो कल का वीडियो डिलीट हो गया है, इसीलिए कल का टॉपिक एक और बार करना चाहता हूं। और हम कर रहे थे रेगुलर लैंग्वेजेस, और हम कर रहे थे मीली मूरे मशीन्स। मीली एंड मूरे मशीन्स को कर रहे थे। ठीक है। और एक बार मीली एंड मूरे मशीन्स को करेंगे। मीली एंड मूरे मशीन को करेंगे। एक बार मैं पता कर लेता हूं कि वो वीडियो डिलीटेड है कि है। नहीं नहीं, एक बार देखते हैं वीडियो है कि नहीं। अगर वीडियो है तो उधर से कंटिन्यू करेंगे, ठीक है। एक मिनट, मैं पूछ रहा हूं कि कल का वीडियो डिलीटेड है क्या। तब तक एक स्टोरी कर लेंगे, ठीक है। तब तक एक स्टोरी कर लेंगे। Deepinder Goyal, founder of Zomato, you know him, right? Founder of Zomato is now investing in deep tech startups like companies building India's first jet engine and starting LAT airspace. He is hiring top computer science and core engineering talent for systems like control, simulation, autonomy, and jet engine design. This marks a new wave in India. Real critical tech work, embedded systems, real-time OS, safety code, ML for navigation. Doing MTech or preparing for GATE now will give you an edge. Will give you an edge, not a backup. You are preparing to build India's future. ठीक है? Deepinder Goyal, the founder of Zomato, is now doing a lot of things. You are now going to see an Elon Musk in India. Very soon, you are going to see an Elon Musk in India, and he will be Deepinder Goyal. ठीक है? I am proud to be an Indian. I am proud to be an Indian, and he is my hero. Jai Hind, Jai Hind, Jai Hind. ठीक है? ठीक है, तो कल का भी आज थोड़ा सा पढ़ाना पड़ेगा। कल का भी आज थोड़ा सा पढ़ाना पड़ेगा, तो पढ़ाएंगे कल का भी थोड़ा सा, ठीक है। तो हम देख रहे थे मीली एंड मूरे मशीन्स। पहले हम देखेंगे मूरे मशीन। पहले हम देखेंगे मूरे मशीन। कंस्ट्रक्ट ए मूरे मशीन। कंस्ट्रक्ट ए मूरे मशीन that takes construct a Moore machine that takes set of all strings over a comma b as input and prints one as output for every occurrence of AB as a substring, for every occurrence of AB as a substring. For every occurrence of AB as a substring, we have to print 1. That's it. Okay. So yesterday we have already seen this, but today I want to just revise whatever we have seen yesterday, and after that we will start. Okay. Okay. So for this question, when you have to print a 1 for every occurrence of AB, when you have to print a 1, right? When you have to print a 1 for every occurrence of AB, there are 3 things you can do. Maybe I will starting with AB. I will take the starting with AB. What is the problem with this? The problem with this is I will print a 0 here, I will print a 0 here, I will print a 1 here. For every occurrence of AB, 1 will be printed. Okay, not a problem. But the problem is even when AB has not occurred, it will print a 1. Okay. So let us say this is state A, this is state B, this is state C. Okay. So if I give the input as A, B, 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 what will happen? From A, on seeing small a, we will go to B. From A, on seeing small a, we will go to B. And from B, on seeing small b, we will go to C. And from C, on seeing small b, we will go to C. And from C, on seeing small c, we will go to C. Okay. So A will give 0 as output, B will give 0 as output, C will give 1 as output, 1 as output, 1 as output, which means when I have seen AB, I am printing 1, but without seeing AB also I am printing 1, right? Therefore, starting with AB is not the right one. Starting with AB is not the right one. Starting with AB is not the right one. Hana. Now we will see containing AB. Now we will see containing AB. Okay. So one more thing that you have to keep in mind is the diagram that I have drawn in the previous slide. This diagram is not DFA. One thing you have to remember is every Mealy machine and every Moore machine both are DFAs. But here I just wanted to show you some small examples. So I didn't draw the NFA for this. Actually, you are supposed to get a DFA. Actually, you are supposed to get a DFA, right? But for this example, it doesn't matter. Okay. Now let us see what happens for containing AB. So I will be in state A, print 0, and I will see a and then I will see a B. Now this will contain AB, this will be B, this will be C, this will print 1, this will print 0, this will print 1 and this will print 0, containing AB. So any number of A comma B's can come. Again the same problem will happen, right? Containing AB means initially there will be any number of B's and then A's and then any number of A's and then B's. This is containing AB. The problem is once I have seen AB, and then if I have seen many number of B's, A on small a will go to B, A on small a will go to B, and B on small b will go to C, and C on small b will go to C, and C on small c will go to C, C on small b will also go to C. What happened is whenever there is a AB, the output is 0 here, output is 0 here, output is 1 here, output is 1 here, output is 1 here, output is 1 here, right? So whenever you saw AB, you are getting a 1. But after that, even if there is no AB, you are getting the output as 1. Therefore, this will not work out. These two methods will not work out. Okay. Now, starting with AB didn't work out, and then ending with AB containing AB didn't work out. So now let's try to see about ending with AB. Will it give me the number of ones whenever AB is seen? Whenever AB is seen, will it give me the number of ones? Okay. Whenever AB is seen, will it give me the number of ones? Okay. So I'm not able to see the comments. I will just I'm not able to see the comments in the screen. So guys, whenever there is an AB, I have to print 1 as output. Whenever there is an AB, I have to print 1 as output. Otherwise, I have to print 0 as output. Whenever there is an AB, I have to print 1 as output. So what I will do is, I will draw the machine for ending with AB. Okay? So if a comes, if a comes, if a comes, if a comes, I am going to give 0 as output, and only if a AB comes, I am going to give 1 as the output. I am going to give 1 as the output. Okay, okay, okay. Fine, fine, fine. Now what happens? Now what happens? Now what happens is, whenever I get a, whenever I get a, whenever I get a, whenever I get a, I'm going to wait. Whenever I get a B, I'm going to wait so that string will end with BA. And whenever I get a, I'm going to wait so that string will end with BA. And if I get a, I will go back and wait for a B. And if I get a B, I will go back and wait for a AB. Okay? I will go back and wait for a AB. Okay? Now, in this machine, for every occurrence of AB, there will be a printed. There will be a 1 printed. For every occurrence of AB, there will be a 1 printed. Okay? There will be a 1 printed. Okay? Okay? So, how can I do this? On seeing A, B, what happens? A on seeing A will go to B, and B on seeing B on seeing B will go to C, and C on seeing A will go to B, and B on seeing B will go to C. Okay? So A is, so for A the output is 0, for A the output is 0, for B the output is 0, for C the output is 1, for B the output is 0, for C the output is 1, for C the output is 1, for C the output is 1, right? So whenever I get a AB, I am getting 1 as the output. Whenever I get a AB, I am getting 1 as the output. Therefore, this machine actually works. This machine actually works. So what is this machine? This is actually a DFA which is accepting set of all strings ending with AB. Haina. But I am using it as a Moore machine by removing the final state, and I am generating 1 as output whenever we reach C. Right? Now I'll give you one question. You answer it, okay? Now I'll give you one question. You answer it, okay? Udaya, tablet. Now I'll give you a different question. You answer this. Construct a Moore machine which will take construct a Moore machine which will take sigma equal to a comma b and produces one as output for every occurrence of BAA. For every occurrence of BAA. You can use the same model. This is the same model question. This is the same model question. You can use the same model that we have used. What is the model? Ending with BAA. है ना? The model is ending with BAA. Ending with BAA. है ना? The model is ending with BAA. The model is ending with BAA. Construct a Moore machine which will take sigma equal to a comma b and produces 1 as output for every occurrence of BAA. ठीक है? Again we will do the same thing. Ending with BAA. So when I see a B, I go to the next state. When I see a, I go to the next state. And when I see a, I go to the next state. ठीक है? ठीक है? ठीक है? BAA, right? Right? Any number of A's come, I will wait for a B. And after a B, any number of B's come, that is still ending with BAA. And after BA, if I get a, after BA, if I get a, I'm going here. After BA, if I get a B, I will go here so that the string will end with ABB. And here, if I see a B, I have to wait for a AA. If I see a, I have to wait for BAA. I have to wait for BAA. Okay. Now, output for this state is 0, 0, 0, 1. You can check it. You can check it by writing the strings. I am leaving it to you. You can check it, right? So whenever you get a BAA, you are going to get a output as 1. And whenever you are getting any other string, the output will be 0. If you want, I will show you. If you want, I will show you, right? Let us say this is state number A. Let us say this is state number A, this is state number B, this is state number C, and this is state number D. ठीक है? ठीक है? Now the input is B, A, B, A. I will be in the state A. I will be in the state A. On seeing a B, I will go to state B. On seeing a B, I will go to state B. I will go to state B. Right? I will go to state B. On seeing a, I will go to state C. On seeing a, I will go to state D. A output is 0, B output is 0, C output is 0, D output is 1. D output is 1. Right, right. And then D on seeing B. D on seeing B will go to B, B on seeing A, B on seeing A will go to C, and C on seeing A will go to D. Again we got the output as 1, right? So whenever I see BAA, whenever I see BAA, I am getting the output as 1. I am getting the output as 1. ठीक है? ठीक है? Okay. So now you understood that if for every occurrence of AB I have to print a 1, then you go with ending with AB. If for every occurrence of BAA I have to print a 1, go with ending with BAA, right? Now if I want to see A1 for every occurrence of BA, then do for ending with BA. Then do for ending with BA. ठीक है? ठीक है? ठीक है ना? ठीक है? Now we will do a different question. Construct a Moore machine. Construct a Moore machine that takes set of all strings over 0 comma 1 set of all strings over 0 comma 1 and Okay. So whenever input is ending with 1 0, we have to print A. Input is ending with 1 1, we have to print B. Otherwise, we have to print C. Otherwise, we have to print C. Right? How are we going to do this? How are we going to do this? It is simple, right? So whenever the input ends with 1 1 1 1, you have to print the output as B. Whenever the input ends with 1 0, you have to print the input output as A. You have to print the output as A. Okay. Now any number of zeros may come. I will wait for a 1 0 or 1 1. Okay. Now any number of ones will come that is still ending with 1 1. Any number of ones will come that is still ending with 1 1. So I will be printing BB only. Any number of ones may come, they are still ending with 1 1. So I will be any any number of ones will come. Any number of ones will come that is still ending with 1 only. So B will be printed. If I get a 0 here, that is ending with 1 0, therefore I will print A. 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 Right? Is this a DFA? 0 and 1 covered, 0 and 1 covered, 1 is covered, 0 is covered. Here 0 is not covered, 1 is not covered, right? For this A, 0 is not covered, 1 is not covered. We didn't say what happens at 0 and what happens at 1. If a 0 comes, I have to again wait for a 1 0 or 1 1. If a 1 comes, I have to wait for 1 followed by a 0 or 1 followed by a 1. Right. So now this machine will print whenever the output is ending with 1 1. Let us say the output is 0 1 1, right? I will start from A. So states are confusing, right? I will say this is state number. BCs are already given here. So let us say this is state number Q0. Let us say this is state number Q1. Let us say this is state number Q2. Let us say this is state number Q3, right? State number Q3. 0 1 1 0 1 1, right? So Q0 on 0, this is Q0 on 0 will stay in Q0 only, and Q0 on 1, let us say this is Q1, Q0 on 1 will go to Q1. See this, Q0 on 0 is staying in Q0 only, and Q0 on 1 is going to Q0 on 1 is going to Q0 on 1 is going to Q1. Q0 on 0 is going to 0. Q0 on 1 is going to Q1, right? And then Q0 on 1, Q1 on 1 is going to be Q2, right? Now what is the output printed? For Q0, the output is 0. The output is C. For Q0, the output is C. For Q0, the output is C. For Q1, the output is C. For Q2, the output is B. For Q2, the output is B. For Q2, the output is B. Hai. So, whenever we are ending with 1 1, the output is B. Whenever we are ending with 1 1, the output is B. Let us see what if we end with 1 0, right? Let us say 0 1 0 is there. Let us see what happens. So initially I will be in Q0. On seeing a Q0, I will still be in Q0. On seeing a Q0, I will still be in Q0, right? Now, on seeing a 1 from Q0, on seeing a 1, I will go to Q1, and Q1 on seeing a 1 will go to Q3. So what are the outputs? For Q0, the output is C. For Q0 the output is C. For Q1 the output is, for Q1 the output is 1. For Q1 the output is 1. For Q1 the output is 1. Q1 the output is C. Q1 the output is C. And for Q3 output is A. Now you got it, right? Whenever it is ending with 1 1, we are getting B as the output. Whenever it is ending with 1 0, we are getting A as the output. We are getting A as the output. Okay, A as the output. पेड क्लास और इसमें ना एग्जाम्पल्स डिफरेंट होता है, कॉन्सेप्ट तो वही होता है. एग्जाम्पल्स डिफरेंट होता है, कॉन्सेप्ट तो वही होता है. ठीक है. नाउ लेट्स डू वन मोर एग्जाम्पल. Let's do one more example. Construct a Moore machine. Construct a Moore machine that takes set of all strings over 0, 1 as input. This to we already done. Construct a Moore machine that takes binary numbers as input, and produces residue modulo 3 as output. Okay, and produces residue modulo 3 as output. For this one we have done a DFA. If you remember long back we have done a DFA. We can use the DFA here, right? Whenever I divide any number with 3, it will give me 3 reminders. One remainder will be Q0, other remainder will be Q1, and other remainder will be Q2. Right. So Q0 will give output 0, Q1 will give output 1, Q2 will give output 2. Right. Now we already know this. On 0, we have already done this earlier. On 1, and then on 0 and 0, and then on 1 and then on 1. Right. This is a DFA for divisibility by 3, है ना? This is a DFA for divisibility by 3. This is the DFA for divisible by 3. This is the DFA for divisible by 3. Q0, Q1, Q2. This is the DFA for divisible by 3. Here remainder is 0, here remainder is 1, here remainder is 2. Right. So this is a Moore machine. This is a Moore machine. ठीक है. Now let's try to construct the Mealy machine using RBR method. Okay. So I will give you 5 minutes of time. Please write the answer in the Telegram channel. Use RBR method and do the same question in 5 minutes. I am giving you 5 minutes of time. Okay. Okay. I'll give you 5 minutes of time. Okay. Okay. Now what is our RBR method? Whenever you divide any number with 3, the number of remainders you get is either you get a remainder as Q0, or you get a remainder as Q1, or you get a remainder as Q2. Now you can write 0, 1 here. You can fill it like this: Q0, Q1, Q2, Q0, Q1, Q2. Now the output associated with each state is, for Q0 it is 0, for Q1 it is 1, for Q1 it is 1, and for Q2 it is 2. For Q0 it is 0, for Q1 it is 1, for Q2 it is 2. For Q2 it is 2. For Q2 it is 2. Right? Right? This is RBR's method, which is very simple compared to drawing the DFA. Instead of drawing DFA, if you go by this method, this is very simple. Okay. Now I'll give you one more question. You solve it. From now onwards, the topic is going to be interesting. So now I'll give you one more question. You solve it. Okay. I'll give you one more question. You solve it. Okay. పరువం వానగా నేడు కురిసేనులే ముత్తు మురిపాలలో ఈడు తడిసేనులే నా వడిలోన ఒక వేడి సగరేగనే ఆ సడిలోన ఒక తోడు ఎదకూరెనే పరువం వానగా నేడు కురిసేనులే ముత్తు మురిపాలలో ఈడు తడిసేను. Construct a Moore machine that takes base 4 number. That takes base 4 number as input. That takes base 4 number as input. Base 4 number as input, and produces base residue modulo 5 as output, and produces residue modulo 5 as output, and produces residue modulo 5 as output. Okay. Now you can directly use RBR's method. Okay. So what is it? The number has to be divisible by 5. The number has to give remainder as 5. है ना? So Q0, Q1, Q2, Q3, Q4. When I divide a number with 5, I will get 0, 1, 2, 3, 4, 5 remainders, and Q0 is the initial state, and they are saying that it is a base 4 number. What do I mean by base 4? There will be 4 symbols, right? 0, 1, 2, 3. So I will write like this: Q0, Q1, Q2, Q3, Q4, then Q0, Q1, Q2, Q3, Q4, then Q0, Q1, Q2, Q3, Q4, then Q0, Q1, Q2, Q3, Q4, right? Now what is the output associated? What is the output associated with each state? With 0, the output associated with 0. With 1, the output associated with 1. With 2, the output associated with is 2. With 3, the output associated with 3. With 4, the output associated with 4. There will be no final state here because this is a transducer, right? So one more point I want you to observe here is, see this. Whenever the input is 3 bits, the output is 4 bits. Whenever the input is 3 bits, the output is 3 bits, 4 bits, right? So I want you to make a small note of it. I want you to make a small note of it. I want you to make a small note of it. Whenever the input contains 4 bits, whenever the input contains 4 bits, the output will contain 5 bits. The output will contain 5 bits. Whenever input contains 4 bits, the output will contain 5 bits. The output is whenever the input contains 4 bits, the output will contain 5 bits. Okay, this point I want you to remember. ठीक है. Where is it? In Moore machine. In Moore machine. ठीक है, in a Moore machine. ठीक है. याद देवा नया. Go to PW app. You will get my notes also in PW app. You will get my notes also in PW app. Okay. You will get my notes also in PW app. So just to, I will show you where it is. Go to PW app, go to free resources. There you will find this course along with the notes. Okay. So whenever the input contains 4 bits, then the output will contain 5 bits in Moore machine. Okay. Now I'll give you one question. I am very sure that no one will be able to answer it. Okay. Before going ahead, let's do one small question about Mealy. ठीक है. Construct a Mealy machine. Construct a Mealy machine that takes binary number as input, and produces one's complement as output. Construct a Mealy machine that takes binary number as input and produces one's complement as output. Construct a Mealy machine that takes binary number as input and produces one's complement as output. Right? So what is the difference between Moore and Mealy? What is the main difference between Moore and Mealy? In Moore, output is associated with state. In Mealy machine, output is associated with transition. For example, if I have to find out the ones complement of a machine, now if I see a 0, it will print a 1. If I see a 1, it will print a 0. Right? Now the output is associated with the transition, not with the states. Now the output is associated with the transition, not with the states. Now the output is associated with the transition, not with the states. Output is associated with the transition, not with the states. Output is associated with the transition, not with the state. Not with the state. ठीक है? ठीक है? This is about Mealy machine. Output is associated with the state is the Mealy machine. Output is associated with the state is the Mealy machine. Now I will give you a difficult question. I will give you 5 minutes of time. Try to answer this. Okay? Try to answer this. Construct a construct a Mealy machine. Construct a Mealy machine for finding 2's complement. For finding 2's complement. Construct a Mealy machine for finding 2's complement, assuming that input is read from LSB to MSB, and carry is discarded. Right? This is not a very easy question. It will take some time. Take 5 minutes and try to do this. Okay? It is not very easy to answer. Try it. Don't give up. Try it. Take 5 minutes of time and you try doing it. I will explain you. Okay? If you are not able to do it, I will explain you. Okay? Story time चाहिए क्या? You want a story? Let's see a story. Dr. Ranjit R. Panatur. Background is he grew up in a remote village in Kerala as a son of a tailor, lived in a 2-room mud house, and worked nights as telephone exchange watchman for 5 years to fund his education. Matlab, I have seen many people, I have seen many struggles by, lekin his struggle is the greatest. He worked as a watchman for 5 years to fund his education. He is a son of a tailor, and he lived in 2-room mud house. Okay. And what is education? His education is valedictorian in economics, St. Pius College, and masters from Central University of Kerala, and PhD in economics from IIT Madras 2015 to 2020. He has done PhD, right? And what are his career achievements? He taught at Christ University, later joined IIM Ranchi as a faculty member, and has published internationally in economics. And what is the impact he has created? He is known as Watchman to Professor. This man is called Watchman to Professor story, right? Watchman to Professor. He is a role model for the underprivileged students and widely celebrated for his journey from poverty to academia. Just imagine one thing. आप ना just imagine one thing. We have everything. We have food to eat, we have a bed to sleep, and we have a roof over our head. There are people who don't have all this, but still they are able to achieve greatness. He is a son of a tailor and lived in a mud house which contains only 2 rooms, and he worked as a watchman for 5 years to save money for his education, and then he has done his masters and PhD and published lot of papers, and he became a professor at IIM, and he became a professor at IIM and published lot of papers, and he is known as watchman to professor. He is called as watchman to professor. If he can do it without anything, without any resources, without having money, you have everything, guys. You have everything. You are watching free videos on YouTube on your phone, which means you have a phone or a laptop. You have everything. Why are you not able to achieve great things? Just think about it. He is an inspiration to many people. He is an Indian. I am proud to be an Indian, and I am proud of him, proud of what he has achieved. Jai Hind, Jai Hind, Jai Hind. Okay. So whatever question I have given you, please try to do the question. Whatever question I have given you, please try to do that question. I'll give you answer in 5 minutes. Okay. Please take 5 minutes. I'll give you answer in 5 minutes. What is the machine? Construct a Mealy machine for finding 2's complement, assuming that input is read from LSB to MSB and carry is discarded. And carry is discarded. Okay. Carry is discarded. टेलीग्राम में देख रहा हूँ आपका आंसर्स। देखते हैं कितने लोग ने आंसर किया है। ठीक है, I will tell you a shortcut. Okay, I will tell you a shortcut. I will tell you a shortcut for this. ठीक है, whenever a number is like this 110100 and you are scanning it from the right side, what is the 2's complement is you leave zeros as it is and first one also as it is. You leave zeros as it is and first one is also as it is, and the remaining part you complement it. You complement it. You complement the remaining part. That's it, over. What is the solution? If I have a number like this 110, you leave the last zeros as it is and the first one as it is, and after that first one you do ones complement 100 100. Simple, right? Now you can construct a Mealy machine. Now you can construct a Mealy machine. Now you can construct a Mealy machine. Now we will construct a Mealy machine. Right? How are you going to construct a Mealy machine? Any number of zeros. One more thing, we are scanning from the right hand side, not from the left hand side. Any number of zeros we get, leave them as zeros, and whenever you get the first one, leave it as first one, and after that any number of zeros you get, you convert them to ones, and any number of ones you get, you convert them into zeros. Any number of ones you get, you convert them into zeros. You convert them into zeros. Okay, you convert them into zeros. Okay, got it? Got it? Any number of zeros, you leave them. Whenever you get the first one, leave it as first one, and after that any number of ones you are going to get. Any number of ones you complement them, any number of zeros you complement them. This is the 2's complement, neglecting the carry. Carry is discarded. We are not worried about the carry. We want to convert a binary number into a 2's complement number. We want to convert a binary number into a 2's complement number. Okay, okay. Now I'll give you a difficult question. This will be difficult to answer. If anyone answers this, you will get in top 100. Show me the answer in Telegram channel. If anyone answers it right, you will be in top 100. Okay, you will be in top 100. I'm giving you a difficult question. Okay, Q0 on 1 is 01, Q2 Q1, Q1 on 0 is 0, 1, Q1 on 0 is 0, 1, and Q1 on 1 is 1, 0, and Q2 on 1 is 1, 0, on 1 is 1, 0, and Q2 on 0 is 0, 1, on 0 is 0, 1, and Q1 on 0 is 0, 0. Q0 on 0 is 0, 0. Q0 on 1 is 1, 0. Q1 on 0 is 0, 1. Q1 on 1 is 1, 0. Q2 on 0 is 0, 1. And Q2 on 1 is 1, 0. Right? Right? I want you to find out what does this machine do. I will give you 5 minutes of time. Write your answer in Telegram channel. I will see your Telegram channel. Okay? I will see your Telegram channel. I will see your Telegram channel. Okay? Okay? Take 5 minutes of time and answer this. Okay? Take 5 minutes of time and answer this. Okay? If you are not able to do this, I'll give you options. Okay? Let's see that you are able to do this. If you are not able to do this, I'll give you options. If you are not able to do this, I'll give you options, okay? If you are not able to do this, I will give you options. Please don't comment too much on the comment section. I will take all your doubts at the end of the class. Please don't disturb others. ठीक है? Please don't disturb others. Let them read and answer the questions. Okay? Okay? So I'll give you options. Option A is it converts 11 to 01, and option B is it converts it gives sum of present and previous bits, and option C is it converts 10 to 00, and option D is none. Sir, can you solve doubt at the end? Only because during lecture we prepare notes. Yes. You write down everything. I will give you time for doubts. I am not able to read the comments. There are too many comments. I am not able to read the comments. After the class is over, I will take the doubt session. If you have doubts, I will take the doubt session. Okay. So Anshu has sent it on Telegram. I will just check it on Telegram. Many people are able to do it, but all of them are not right. Some of them are able to do it right. All of them are not right. All of them are not right. All of them are not right. Okay. So now if you observe it, will it convert 11 to 01? If I give 11, what happens? I will be in Q0. If I see a 1, I am generating 01. So first option is wrong. If I see a 1, I am generating 01. If I see one more 1, I will be in Q1. Q1 on 1 is going to give me 10. So this is wrong. Option number 1 is wrong. Let's see option number 2. Anshu, you are almost right. Anshu, your answer is almost right. Anshu, your answer is almost right. There is a small problem. I'll explain you. Okay. Sum of present and previous bits. Let us say I have given the input as 1011. Initially, I will be in state Q0. On seeing a 1, I will go to state Q1. And what will be the output produced? 01. Now I will be in Q1. On seeing a 0, I go to Q0. And what is the output produced? 01. And I will be in Q0. I will see a 1. Then I will go to Q1. What is the output produced? 01. Now I am in Q1. On seeing a 1, I will go to Q2. What is the output produced? 11. What is the output produced? 11. 10. Output produced is 10. If you observe it, every time the last two bits, present and previous bit, is giving us the 0. Present and previous bit is giving us the sum. Just observe it. 1 plus 0 is 1, therefore it is 1. 0 plus 1 is 1, therefore it is 1. 1 plus 1 is 2, therefore it is 2. Therefore it is 2. Okay? Okay? I will answer all your doubts at the end of the session. I will answer all your doubts at the end of the session. I will answer all your doubts at the end of the session. Don't worry. Okay? 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 Construct a Moore machine for counting. Construct a Moore machine for counting number of A's. Construct a Moore machine for counting number of 8's mod 3. Construct a Moore machine for counting number of A's mod 3. This you already have done. Number of A's mod 3 we have already done in DFA, right? Let us say when I count mod 3, I will get 3 reminders 0, 1, 2. Hai na? 0, 1, 2. So Q0 is 0. Q1 is remainder is 1 and Q2 remainder is 2. Q2 remainder is 2. Right? So B, I will count A's. A, B, B, B. ठीक है. Now I want to convert it into Mealy machine. What is the main difference between Moore and Mealy? What is the main difference between Moore and Mealy? The main difference between Moore and Mealy is very simple. In Moore machine, output is associated with the state, and in Mealy machine, output is associated with the transition. है ना? है ना? So what you should do is you should move the output from the state onto the transition, which means for every incoming edge, you have to move the output to the transition, right? I'll just show you what I will do. Q0, Q1, Q2, right? Now there is an incoming edge. Now there is an incoming edge on B. 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 Right, right. Now what is the output on Q0? It is 0. So write 0 here. Right? Now there is an incoming edge. There is an incoming edge to Q1. What is the output of Q1? The output of Q1 is 1. So you write like this. A1. A1. Right? Now there is incoming edge on Q1. What is the output on Q1? 1. So you write 1 here. Now there is an incoming edge to Q2. What is the output? What is the output? What is the output? What is the output? There is incoming edge on A, Q2. What is the output? What is the output? So Q2 output is 2, therefore it is 2. Q2 output is 2, therefore it is 2. There is an incoming edge on B. There is incoming edge on B. what is the output? The output is 2, therefore you are going to write the output as 2. Therefore you are going to write the output as 2. Right? Right? Now, there is an incoming edge on Q0 on A. What is the output with Q0? It is 0. So you are going to write 0. It is 0. You are going to write 0. You are going to write 0. Okay, so what did I do? I have constructed a Moore machine and I have converted it into Mealy machine. How? By moving the transition from the states. By moving the transition from the states to the transition. I am moving the output from the state to the transition. From Q0, 0 was here earlier, I moved it here, and 0 was here earlier, I moved it here, which means for every incoming edge I am just moving it. For every incoming edge I am just moving it. Okay, I hope you are able to do this. Now now let's see how to convert a table. Or before that, let's do one thing. Let's take this question. Q0, Q1, Q2, AB delta, Q0, Q1, Q2, Q0, Q1, Q2, right? So what is this? This is modulo 3, residue modulo 3 is some kind of similar question. Q0, Q1, Q2, Q0, Q1, Q2, and the output is 0, 1, 2. Now what is this machine? This machine is Moore machine because for every state there is a transition. For every state there is a output, isn't it? For every state there is a output. 0, 1, 2, there is a output, right? Now I want to convert it into Mealy machine. I want to convert it into Mealy machine, right? How can I convert it into Mealy machine? Just take the transitions, just take the output from the state and put it on the transitions. Okay, just take the Q0, Q1, Q0, Q1, Q2, Q0, Q1, Q2, AB, 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 okay, if you are not able to understand it, you please leave the class and you go to 𝐂𝐚𝐿's class. Okay, you don't have to say that he is the best here. Okay, so Q0, Q1, Q2, what I will do is I will write the transition table same. I will write the transition table as same. Q0, Q1, Q2, Q0, Q1, Q2. Right. Now what happens to the outputs? Now what I should be doing with the outputs is the question. Okay. So output associated with Q0 is 0. Wherever you see Q0, you put 0. Output associated with Q1 is 1. Wherever you see 1, you put 1. Wherever you see 1, you put 1. Output associated with Q2 is 2. Output associated with Q2 is 2. Output associated with Q2 is 2. Wherever you see 2, you are going to write 2. That's it. Simple, right? This is the Mealy machine. What did we do? We have taken the transitions from the states and we have put them in the transitions, right? We have taken the output from the states and we have put them on the transitions, right? Right? Got it? Now you do one thing. I will give you a Mealy machine. You convert it into Moore machine. Okay? I'll give you a Mealy machine. I'll give you a, let's do a Moore machine. Convert it into Mealy. Okay? A0, A0, B0, B0, C1. A0, B0, C1. Okay? Now, on seeing a I am here. On seeing a B, I am here. On seeing a B, I am here. On seeing a B, I am here. And on seeing a I am here. And on seeing a I am here. And on seeing a B, I am here. Right? What is this finite automata, guys? This finite automata is, I guess, ending with AB, isn't it? This is ending with AB. Ending with AB, right? Now I want to convert this into Mealy machine. This is a Moore machine. Output is associated with the states. Output is associated with the state. This is a Moore machine. Now I want to convert it into Mealy machine. Now I want to convert it into Mealy machine. I want to convert it into Mealy machine. Okay. How can I convert it to Mealy machine? You just write the output from the state onto the transition. That's it. I will just draw it everything. A, B, C, right, right. I will just move transition. I will just move output from state to transition, right? State to transition for every incoming edge, right? There is an incoming edge here. This is B, this is A, this is A, this is B, this is B. Okay, this is B. Okay, I will move so I will move. Thank you, Bharadwaj. Thank you, Kiran Bharadwaj. See, you cannot say that some faculty is good or some faculty is bad. All that you need to do is learn from everyone. If you are not able to understand anything, you can ask us. We will give you. You cannot say that I'm not able to understand, Ankit sir is the best. He might be the best. That I totally accept that he might be the best. But what is the problem with my teaching? If you don't understand, just tell me what is the problem with my teaching. Then I will definitely improve. Okay? Then I will definitely improve. Okay? So this is an incoming edge on A and the output is 0. This is an incoming edge on B and the output is 0. This is the incoming edge on B and the output is 0. This is the incoming edge on A and the output is 0. This is the incoming edge on C and the output is 1. That's it. That's it. Is one more edge missing here? That's it, right? What did I do? I have taken the output from the states and I have put them in the transitions. Right? Now let's now convert. Let's now convert now let's now convert a Moore machine to a Mealy machine to Moore machine. Okay. What is this Mealy machine? This Mealy machine is ones complement machine. It is converting 0 to 1 and 1 to 0. It is converting 0 to 1 and 1 to 0. This is a ones complement machine. This is a ones complement machine. And now what I want to do is, I want to convert it into, this is a Mealy machine. This is a Mealy machine. Now I want to convert it to Moore machine. Now I want to convert it to Moore machine. Okay. Now if you observe it, I have to take the output from the transition and put it on the state. I have to take the output from the transition and put it on the state. Okay. I have to take the output from the transition and put it on the state. Output from the transition and put it on the state. Okay. Put it on the state. Okay. Okay. How can I do it? How can I do it? Break and story time. Okay. Let's do a story. Okay. Let's take a break and let's do a story. Okay. Dr. 𝐂𝐚𝐴, background, born to a poor mango farmer in a rural Tamil Nadu, studied in Tamil medium school, went barefoot to college. He didn't have shoes to wear. He went barefoot to the college and wore trousers for the first time at MIT. He wore trousers means pants. Till then he was wearing only shorts. He wore trousers for the first time at MIT, first graduate in his family. And his education is, he did his BTech from MIT 1980 and he did his ME in aerospace in IISc. By ये तो IIScian है, मेरा कॉलेज है IISc. I am proud to be an IIScian. See how much he struggled and how much he achieved. Okay. मेरा भारत महान, IISc जिंदाबाद, जय हिंद. ठीक है. Now he has done ME in aerospace in IISc Bangalore and PhD in aerospace engineering from IIT Bombay 2006. And what are his achievements in his career? He joined ISRO in 1982, led key rocket programs. He has led key rocket programs, including cryogenic tech, became ISRO chairman in 2018, led Chandrayaan-2 and set world record with 104 satellites in one launch. He has set a world record by sending 104 satellites in a single launch. He is not an ordinary guy. He is not just a hero. You can call him God of Indian aerospace. Okay. Okay. What is the impact? Known as the Rocket Man of India. He is known as the Rocket Man of India and he was awarded Padma Shri and Padma Vibhushan and remains a powerful inspiration for students from rural backgrounds. What a personality he is. Again, I will tell you, he is born to a poor mango farmer in a rural Tamil Nadu district. In a very rural place in Tamil Nadu, he is born to a mango farmer and he studied in Tamil medium. His education was in Tamil medium and he went barefoot to the college. उसके पास shoes भी नहीं था, चप्पल भी नहीं था. He didn't have shoes, he didn't have chappals. He went barefooted to the college and till he reached MIT, he never wore pants. He never had pants to wear till he reached MIT. When he reached MIT, he wore pants. Okay. First graduate in this family. BTech from MIT in 1980. ME from aerospace in IISc Bangalore. PhD in aerospace engineering in IIT Bombay. And joined ISRO in 1982. Led key rocket programs including cryogenic tech. Became ISRO chairman in 2018. Led Chandrayaan-2 and set world record with 104 satellites in one launch. Just in one launch, he sent 104 satellites. And what is the impact? Known as the Rocket Man of India, he was awarded Padma Shri, Padma Vibhushan, and remains a powerful inspiration for students from rural backgrounds. for students from rural backgrounds. He is a legend. He is a legend. And he is an IASCN. He is an IASCN. Okay. Now let's get back. So now we will convert a Mealy machine to Moore machine. In Moore machine, what did we do? We have moved the output from the state to the transition, right? Now in Mealy machine, we have to move the output from transition to the state. But the problem is there are two edges here. Both of them are having different outputs. Therefore, I cannot move both the outputs onto A. So I will split A. A will be split into two parts. One A will have 0 as the output. Other A will have 1 as the output. You can take anything as the starting state, not a problem. Okay, not a problem. Now, A on 0 is going to 0 and outputting 1. A on 0 is going to 0. A on 0 is going to A and outputting 1. A on 0 is going to A and outputting 1. And A on 1 is going to A and outputting 0. A on 1 is going to A. A on 1 is going to A and outputting 0. I will not write that. Okay. A on 1 is going to A and outputting 0. And A on 1 is going to A and outputting 0. A on 1 is going to A and outputting 0. Again, A on 0, what is it doing? It is outputting 1. And A on 0 is outputting 1. And A on 1 is outputting 0. A on 1 is outputting 0. Okay. This is about Moore machine. We have converted a Mealy machine into Moore machine. We have converted a Mealy machine into Moore machine. Okay. Okay. Okay, fine. We will end the class. Okay. We will end the class here. We will end the class here. Time is almost 1 o'clock. Okay. So we will end the class here. I will continue tomorrow. Thank you guys. Thank you all for coming. Okay. Thank you.